Okay. So today I'm going to be talking to you guys about reproducible workflows, like different approaches and different tools we can use to make our workflows reproducible. So that's what this is going to be about. I have some live coding worked into this a little bit, and if you guys have questions at any point, just interrupt. Okay? Just shout out. This is our goal. We're going to learn how to a computing environment that fosters reproducibility, so these fundamental skills. And so what we're going to talk about are what reproducibility means for us here specifically, because there's actually many definitions of this. The different components of a reproducible workflow, and a demonstration of some tools to achieve a certain level of reproducibility. So we're going to step through these things. Before we do that, I want to provide some context for what we're trying to accomplish here as it relates to what's been called the replication crisis in science. Sometimes these two things are conflated with one another or thought to be the same thing, and there's some important contextualizing to do here. So what do we mean by the replication crisis? So this is from a somewhat recent survey reported in Nature that found that researchers from different fields fail to reproduce their own research or that of others a distressing amount of time. And so this includes cases where experiments or studies are being rerun with new data and scientists are failing to find the same result, but it also includes cases where researchers are using the same data and code and they cannot reproduce their same results or that of others. And so some reasons for this are listed on the right, and they're varied and include different statistical and cultural issues that are pervasive in science. And among these, we're going to focus on two. They're just related to data and methods. And so we're focusing, hi, come on in, to the extent that these are organized in such a way to make a reproducible workflow. Just aside here, it's worth pointing out that scientific journals are moving more and more towards open data policies. This is the open data policy from Science, where authors have to provide all code and data associated with their article. And this is partially to help mitigate this replication crisis, make science reproducible. It's worth reading some of these, they're pretty hilarious. So this doesn't always mean that the data requests are being honored by authors, or that even journals are actually making authors do all this stuff that they should be doing. So these are examples of very unreasonable requests, responses to people requesting data. And so don't be like this. And also, if you get a response like this, this is not an acceptable, that's not an acceptable way to be told to, they're not going to give stuff to you. And so the point is that even though we have more of these open science policies, these barriers remain. And so what we're going to show you today, though, is that even if you had all this data and code in hand, there's still no guarantee that what you're trying to do is reproducible. So, all right, we're going to define the problem as it relates to us in this course. So, past you has done some kind of analysis. You're really proud of it. It works really well. You're thrilled. And then you put it down and return to it at some point in the future. Whereupon you're unable to repeat the steps of what you did. Okay, so you're looking at your code, you're trying to get the same answer, and it just doesn't work. And so, how does this happen? Does anyone have any ideas? I mean, you have all your code and your data, but you just simply can't reproduce your own work. Yeah.
Not well commented, so it's confusing.
Yeah. This is
when we're trying to modify it or something.
Right. We all do this. We write code frantically, and then we don't document what's happening, and then we have no idea. We're looking at our code, and it might as well be.
Especially with deadlines in mind, we forget to comment.
Yeah, that's one great example. Any others?
Maybe we run with a lot of parameters and forgot which specific set of parameters we used before.
Yeah, so that's kind of feeds into this documentation thing, not just the code, but just sort of the overall meta approach you're taking to it. You're like, what did I do? Yeah. Any other suggestions?
Maybe some environment.
Yep, that's the other big one. Your future computer is not the same as your past computer. Your future, it might be not even the same physical box. Might be the same computer, but your operating system's been upgraded. They upgraded some key system libraries and nothing works. This happens all the time when working with spatial data, especially in R, and the underlying R system libraries that they rely on in advance. So yes. And so for us today, reproducibility will mean our ability to repeat the steps in an analysis, either our own or someone else's, and arrive at the same set of results within a reasonable amount of effort and time, assuming we have all the data and code in hand. Okay, so we're going to assume that in this situation, it's not like, oh, I saw someone do an experiment or a study and they collected a set of data, and then we go out and repeat that and collect our own data and we try and get those results. That's part of this replication crisis, but we're going to talk about something very specific, like literally like, here you go, it's the data and code, make the same figures, get the same outputs, whether that was your past self or someone else's, that's what we're talking about doing. Does that make sense to everybody? So kind of like, should be a much more manageable version of this problem, than the larger version of reproducing other people's work. But it's not. So, okay. So these are the core components of a reproducible workflow. And I'm gonna step through each of these. We're gonna talk about each of these a little bit. And I'm gonna be focusing on the R programming language, although similar tools exist for Python as well. And this is just because my familiarity with R, and this is what I use. And so these R tools rely on system libraries or web services, which we'll also discuss. And so the first is documentation. We're going to step through using R Markdown to improve the documentation of our code. How many of you guys have familiarity with R Markdown already? Or just using, okay. The second is version control, which refers to a method of keeping snapshots of our code as we work on a project, and we're going to use Git for this purpose. Continuous integration is the practice of systematically integrating these snapshots into a shared repository as part of a team, all using Git, and for that we're going to use GitHub. And we don't just want snapshots of our code, but also of our computing environment. And so in this case, specifically our R computing environment. And so here the RENV package, is our friend for doing that. And lastly is containerization, which refers to making sure our programming language, here R, as well as our OS, and all our system libraries on which R depend are reproducible. So a little self-contained universe of reproducibility. And so for this we use Docker to make these images. And then we can manipulate them within R using the Rocker RENV package. We're not really going to discuss containerization today, but I just want you to be aware of it. Right, and also I'm not going to talk today about how we store, document, version control, and integrate data, because that has their own nuances and that would be covered somewhere else. So we're really just going to talk about these first few steps. Okay, so this is some code I wrote from a while ago. I thought it was pretty good, but it's really not that great. And so does anyone have any ideas like why, from a reproducibility framework, this code sort of like is a bit of a letdown? How many of you guys know R in general anyway? Sorry. We all pretty familiar with?
A little bit more Python.
Okay. You don't really need to focus so much on like the R specifics of the coding, but just kind of look at, go ahead.
Something that annoys me when I'm using someone else's code is the directories. If they are like in their own computer space, relative to the code, it's just like...
Yeah, it's a disaster. Super obnoxious. Never use absolute paths. Like use relative paths to where, like set a folder where you're putting something and make all your paths relative to like that position in the thing. That way if someone else has your full directory and they're working with it, it's like, again, it's this self-contained thing. Exactly, that's one point. Anything else?
Line 9, I'm not sure, but it seems like it is commented code, and I don't understand whether we need it, or we might need it in the future, or why author decided to comment it and keep it here.
Yes, exactly. So you're talking about this line here.
Yes.
I don't remember. This is actually some code that I was working with after a year of not working with this. So I thought this was a good example. I have no earthly idea like what was happening here with line 9. And I think it relates back to this comment on line 6 from some mysterious human being named GH telling me to do a thing or not do a thing. Did I do that thing? What was the right thing that we were supposed to do? Does this code actually reflect that? I don't know. This was causing some stress and agita. So like you can already see this is the case. Some other, I'll just see moving along. It's not documented at all. I have no documentation here about this thing. It's just like a line of code. Some of these libraries that I'm using, I'm not even using down there. So I don't even know like why did I load them? Like are they necessary for this? If I want to like know my computing environment. So yeah, so this is an example. These two libraries are not being used at all in this code, yet they sit on top, contributing to some cruft. The file paths, the weird comment that you correctly pointed out, and just no documentation in general. And so Before I get into R Markdown, I just want to say a few words about coding in general. As you correctly pointed out, it's often the case that we're coding phonetically, quickly, we're in a rush, we're faced by some deadline, and this usually leads to our code lacking documentation and testing. And so a good first step in general in reproducibility is just to slow down this process and adjust your mindset from, I forget this fellow's name in the show here, where we're like kind of like communicating our manifesto in a crazy fashion to other people, which is often how we code, and instead kind of look through it of the lens of always being on stage in public with many others looking over your shoulder when you're coding, which is kind of terrifying, right? Like, it's almost like if you were coding and you had like a public repository and you were coding live in there. Like, no one wants to, like, it's like me being up here, right? Like, nobody really wants to do that all the time. But when you do this, you become more diligent, slower, thoughtful, and more deliberate. And this just contributes to less mistakes and enables you to take the time to code and document more properly. So this is just a general way of thinking you should try and embrace as much as possible. And so first we're going to talk about improving documentation, and for that I want to just work through some R Markdown. So R Markdown is this really nice authoring framework for in R for data science. Let's see, you can save and execute and display code from multiple languages, and you can generate these high quality outputs. And so R Markdown is, yeah, go ahead.
So what is this similar, is this like a package or?
R Markdown is a package, and it relies on markup languages. And so let me just walk through the rest of the slide, and then if you have the question, I think I might clarify.
More like, what is the similar Python package for this?
Jupyter Notebooks,
Oh,
like
okay.
would be an example. So this is like the R implementation of Jupyter
Oh, okay.
Notebooks. Personally, I find this sort of Markdown, like markup framework in R to be a lot more extensible than I've seen in Python. But part of that, like I don't, like Jupyter Notebooks to me often don't look as pretty and you can't make as many types of things. This could be some naivete on my part, maybe it's actually fantastic, but from my experience, I've been more impressed with like this overall R, approach to it. So, so they're very similar to Jupyter Notebooks, and before working with it, I'm going to clarify some terms that are confusing. And so broadly, Markdown is a type of markup language, which is a little weird. And so a markup language is a computer language that uses tags to define elements within a document. So you have some chunk of a document and you like wrap it in a tag, and then maybe you wrap that in another tag, and you have like nested tags. And so other examples of this are latex or HTML or XML. And basically Markdown is just offering you a nice shorthand way to create HTML code or some other markup code. And you wouldn't want to write in HTML anyway, maybe because it's just kind of cumbersome to read and write. And so it's just worth pointing out how this works. And so you start with an R Markdown document, which is R's implementation of Markdown. Then the R package knitter knits the R Markdown file that turns it into a generic Markdown document. And then there's this tool in your computer called Pandoc, which is then used to convert this between different markup languages. And so Pandoc is like a Swiss Army knife where you like give it one markup language and you say, I want this other one out, and it pops it out. So the usual implementation of this in R is you're like, here's a Markdown document, which is a type of markup language. I want an HTML document. And Pandoc goes, oh, I know how to do that. Take these pieces, move them around, like pump this thing out. So that's what happens. And so Pandoc is this universal file converter that is a system library on your computer. It's separate from R, so it resides elsewhere. And you don't have to do any of these steps in R. You literally press a little button and like boom, 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 boom. It just all goes through and the thing comes out at the end. It's very handy. So how do we make a Markdown document in R? It's super simple. You basically just go here, new file. You take R Markdown. And these are the types of outputs you can make from this. And then you have to enter some stuff which will be part of the YAML, which I'll describe in a minute. And then that document just appears in R. So here's an example of that, and I'm just going to step through these elements quickly. So the YAML is this thing at the top, okay? That directs what output to make, and at a minimum, you just need the output and the title. And YAML stands for yet another markup language. So you're actually marking up your markup. And I know this, like probably you're just like, what the, like this is just bonkers, but you get used to this part very quickly. So let's see, so chunks with R code and options for how the code is executed to deal with. These are in between, you have these chunks right here. So this is a chunk of R code, and you have your R code in there. And then these are various options that you can put for each chunk to show like whether you want to show the code or the output or how you want to structure the output. And then you can have some like bits and bobs up here that are more related to this that set like things for the document as a whole. So if you never want to show the code, you can specify that up there and you don't have to specify that for each chunk. So in between the chunks, you write markdown or text, which can be translated to HTML. And so this is like where the documentation really comes in. This is kind of the magic sauce of what you're doing. So you can put text, you can put latex equations, you can put images, you can put anything in here really. And then finally when you knit all this document together, you get this thing where the code, the output, and the documentation is like seamlessly integrated in a beautiful way all in one place. And this really contributes to essentially better documentation. And then when you change the code or something, you just change it in this file, and then the output is like immediately updated right in the file too. So maybe like the figures change or something like that. So there's this like pairing between like what you're writing and what you're creating and how you're describing that through documentation. So after knitting, you get this nice HTML output, and this file is really fungible. So you can easily share it. It opens up directly in any browser, and also you, the author, have the underlying R Markdown file that generates this. And so what we're talking about is trying to replace using R scripts as much as you possibly can with something like R Markdown. And I get, well, in a lot of situations, you can't do that. Like if you're on a cluster and you're trying to, execute a job in like some large way, like, you're not going to use Markdown necessarily. But, to the extent possible, this gives you some real advantages. So there's other useful YAML options as shown here. Sometimes you want to use specific HTML code directly in R Markdown and you want to customize it. And to do this, you use what's called a cascading style sheet or CSS, which has these little extra bits and bobs of code. And this is just referenced here in this line. So you might have a CSS file elsewhere and you just got to point to it essentially through this thing. Or sometimes you want to embed HTML code directly in Markdown, and you can do that like this, like right down here. And you can add other things like date and some thematic components to make it look prettier. All right, yeah, so that's that example of the CSS, and there's okay. Right, yeah, that one's okay. So R Markdown is really versatile. You can make reports, websites, applications. This entire presentation is made in R Markdown. It's with Porto. And this versatility is basically built on this like large set of underlying R packages, which are shown here on the right. And so I'm not going to take the time to click on these other examples to show you some various versions of this, but you can make like fairly sophisticated looking documents. Actually, let's do one and just see what the heck happens. So can you see this? This is a book down file. And so this has like a Bayesian model that I've worked on. So this is all like the description of that model. This is all made directly in Markdown. I've embedded the LaTeX code for that. I have these things over here where now when I'm fitting this model, I'm making these these outputs like just right on the fly. So every time I update this model, all these things update. And so you can make fairly sophisticated documents this way. And again, you can just share these directly with people, by email or whatnot.
What is the visualization showing here?
Hmm?
What is the visualization showing here, like the length of this different?
Oh, that's just like summaries of Bayesian posterior intervals. Like so, it's like a big Bayesian model, and that's just like the output of like the parameters. I'm summarizing that. You don't have to know that for the purpose of what we're doing. But yeah, of course. Okay, hold on. And I knew in doing that I kind of screwed myself up here, so. Bear with me one sec. Is everything okay so far? You guys make sense what I'm talking about? I bet you probably already know a bunch of this, but I think for those of you that doesn't. So here's an example of that bad code again. And so what I'm going to do is show you how we deal with that. And so this R Markdown file here. And so this is that same code now re-envisioned in this framework. So what are some things that you can see just looking at this that kind of, from a reproducibility perspective, are better than the original code? Can you guys read this? I know the text is kind of small, but yeah.
Yes.
Does this kind of make sense? Like we have, for instance, these are the specific packages that are being loaded now. So this is some information about the computing environment. I have like an actual purpose of what the heck this thing was for. My code, I don't know if you've noticed, but there's a lot more little within line documentation showing like what does what and where. Is the date it was actually done. Some people leave off the date all the time. You have no idea. Scroll down, and this is actually output. From this thing. So if I change this code, this is the output that is produced down here. So everything's kind of in one place. One thing that's not here is that weird comment, or like the commenting out of that thing. That's not here. We're going to get to that when we talk about Git. Okay, so I haven't just swept that under the rug. But essentially, this is better documented code. So this is like the kind of documentation level you should sort of aim for, and also Markdown's a really handy way to get there. So okay, so let me go back to the. Okay, so now I'm going to move on to version control and continuous integration. So again, version control just refers to the practice of keeping snapshots of our code as we work on a project, and we're going to use Git as our version control system and RStudio as a replacement for the command line when interacting with Git. You can do it all from the command line, no problem. RStudio is often a handy way to do that with a GUI without being on the command line. And then continuous integration refers again to this practice of systematically integrating all these snapshots into a shared repository as part of a team of people. And you can do continuous integration with a remote repository just yourself too, but it really sort of shines when you're doing this as a group. Okay, so documents are not static. We often make changes to them either ourselves or as part of a group. And we also have confusion about tasks we're supposed to do as part of a group, either ourselves or maybe as part of a team. And so this is that comment from above that I was talking about, which I put here. And I didn't show you this, but I didn't just have one file from before. How many of you have been in this kind of situation? All the time, right? This sort of hellish, mental situation. I don't actually know which of these files is the most recent file. And I don't know which of these files dealt with this comment, and I don't know how I was actually supposed to deal with this comment. And so you can think of these files as all as snapshots of the code at different moments in time, right? Like when you save it with something new, you're making a snapshot. And we're storing these snapshots as a collection of unordered files in a way that is not immediately obvious, which is the correct one to be using. So instead of multiple files, how about instead we work with one file that's with track sequential changes? And that's essentially what Git is doing. And Git is this version control system for tracking and managing changes made to that file or set of files. We're going to think of it right now with just one file, but it works perfectly well with many, many files, okay? So don't think it just has to be, I can only have one file in a repository. You can have, as many as you like. And so instead of a group of files or snapshots, we'd rather have one single file whose changes are captured with an ordered series of commits or snapshots using Git. So here, each commit or snapshot, each of these is a separate commit, would be this file changing, as it moves through time. Does that make sense? We're going to go, okay. So I'm going to talk about Git for a little bit. How many of you have used Git before, familiar with it? How many of you would say you're an expert with Git and all that stuff?
Not expert.
Okay, so if you know all this stuff, bear with me. If not, and this is confusing, it is confusing, but in the end, the silver lining is you just kind of use it. You don't really have to know a lot of the nitty gritty, okay? So I just get usually a wide array of expertise with Git. So here we go, and then there'll be a pause. So it's just be a brief moment of badness, kind of like getting your teeth pulled out.
I have a quick question. Yeah. Is the different versions, the different commits stored like C++ linked list? It looks like that. Is it stored like that?
No, let me explain for a sec and then ask again. So let me just explain how this works and then ask your question at the very end, okay? It's basically just text. It's just stored as text. There's no real, as far as I know, Git is probably in C++, but what it's storing is not done that way. So Git stores commits in a linear ordered fashion, much like this old-fashioned like music tape right here. So these ordered changes are stored on a branch, and there can be multiple branches, but we're going to focus on just one, and it's called main. You can have many branches, but again, just pretend there's one file on one branch. The head points to the branch tip, and that's the most recent commit. But it is easy in Git to point to an earlier commit and then re-record with new changes from there on. That's, I think, where this tape analogy comes in. So you can just back this up and like start recording again. And so for each of these commits, you write a message. And along with that message, you have your username as well as the previous commit. And all that information is taken together to generate this unique hexadecimal number, which is called a SHA value. So it's just taking everything, like the entire snapshot of the repository at that time, plus the metadata, which is your username, and like the SHA value from the previous commit, and the message you write, and it's putting that through this SHA generating process, and it's getting this unique number that basically can only be arrived at through the state of the repository right now, as well as everything in the past. Does that make sense? And that's this number right here. And that's why these little arrows are pointing backwards here, to show you that it pulls this into the next one. And so that's what's generating these things. So this is like the SHA value for this latest commit, and up here it's just showing you like an abbreviated chunk of that. You often don't talk about the entire SHA because you can go out like 10 digits and it's unique. And so the same data always produces the same SHA, and this is what guarantees data integrity with Git, as there's this one-to-one correspondence between the SHA value and the history of the snapshots up to that point. Does that make sense? Do you still have the question you were asking?
I mean, it's irrelevant, so I wanted to ask it. But I find the analogy to audio cassettes odd, because audio cassettes you would just overwrite it, but here it's new text, right?
Yeah, but you can actually go back in time. You could be at this point, and you could check out the state of that file here, and you could go here, and then suddenly, I'm going to explain the working directory in a minute, but suddenly everything appearing on your computer for that file would be as if you magically went back in time to this point in time. And then you may make changes,
Right.
and then commit, and then you have entirely new sets of changes, so then you're rolling forward as the tape. So this is kind of like, the analogy is like, rewind the tape a little bit, you press record at a new point in time.
Oh, okay.
Yeah, it sort of falls apart because you can roll back for one file and not another, but in our world here, we're just on one branch, we have one file, like you would just be moving on this like tape thing. So that's why you had a question as well.
Isn't this like the blockchain technology?
Yeah, blockchain is based on
blockchain. Right?
Yeah, yes, blockchain uses SHA and hexadecimal and that whole thing. I don't really know exactly so much how blockchain works, but there was a lot of like similarities between when that was like super big in the the news, that and like this sort of Git thing.
Okay.
So yeah. Okay. So we can also track multiple files as well with Git. However, to understand how this works, we need to define 3 key locations from Git's perspective. And the first is the working directory. And this is just all the files as you see them on your computer. Like if you have a folder that you're tracking stuff with Git, you go in there and your files just as they exist, like as if Git didn't exist at all, that would be your working directory. So that's like basically the place on your computer. The second is the staging area or index. And this is like this temporary holding pen we put our changes into before committing them. So picture this as like this magical bin. You're walking around this and you want to put certain commits in there and then you're going to do a thing with them. So it's like separate from what you see as the files on your computer. And then the repository is the place where all these snapshots are stored behind the scenes. Okay, so that's like something separate. So the staging area and the repository, they're hidden away from you. Like if you're in a folder, you're going to see all your files, and then there's going to be this, I'm going to show you this little .git hidden folder, and that's where all this other jazz is happening. Okay, so just in your mind, picture these 3 areas. And so I want to explain this using the supermarket analogy. And so the working directory is the supermarket, and the items on the shelves are the files. Okay, so that's it. There's this initial snapshot or commit, so a photograph of the supermarket before anything has changed. So picture like all the stuff's on the shelves, these are all your files, we take a picture of that, and that's our first snapshot. Over time, some of the files are modified, like some files are added, some files are removed and deleted since this first snapshot. And so we have a change from the condition of that first snapshot. And your job is to put some of the changed files or the modifications or deletions into the shopping cart. So here, the shopping cart, what do you think the shopping cart is representing in this, on this thing?
Staging area.
Exactly. We need the shopping cart, right? Because otherwise, we would have to like make new snapshots of everything all at once. You know what I mean? So like the shopping cart allows you to be like, these three things relate to something I did. I want to make a commit based on them. These other things are related to some other task, so I want to kind of keep those separate. So the shopping cart is where you put the changes, you know, that you want to record at the time. Okay. And then you take the shopping cart and you go to the cash register. And the cashier, which is Git in this case, takes each of the files in your shopping cart and looks at that first snapshot and updates that first snapshot to reflect the changes to that file. So if you had a file from before and you added some lines, the cashier is like, okay, I gotta add these lines. You deleted some things or added some files, it just handles all that right at the cashier. And then when you check out or pay, Git then saves this updated photograph as a new snapshot in the repository. And we refer to this process of checking out or paying as making a commit. And so we talked about this, like why we bother with the shopping cart thing. Let's say you have your snapshot of all your files and you had like 20 tasks to do today. It was like one of these banner days, you were super productive. And these tasks were like on all different types of things. And so you made some code changes related to one thing, you made some code changes related to another, you wrote some stuff, you did all these types of things. If you make this one giant commit, it's like you're kind of just saying, I changed a million things at once. It's like really hard to kind of keep track of like what those changes were. So it's better to break these up into these little small things where like, I fixed the bug that I found related to whatever. These are the specific changes that relate to that. I make that commit. I added a new feature. These are those specific changes I made to that add new commit. So without the shopping cart, you can't really make that happen. Does that make sense to people? Okay. And so this all sounds very complicated, and I'd be lying if I said it wasn't, but from your perspective, this is what you see in the folder when you're version controlling. This is the old thing on the left. Now we have just, well, I said one file, but really there's two because it relies on some data. And everything else is happening in this little .git folder that you don't have to pay attention to at all. Okay, you're going to interact with the stuff in there through some commands, but all you just see are the files in your working directory. Okay, and you're going to manage Git with this small handful of commands. Does that make sense? Okay. Just take a sec. It's just like the pause slide. So everyone's cool with Git? We're all good? All right. My mileage varies when I explain this to people. Sometimes people are like, I don't know what you just said. So I'm glad you guys are all good with this. Okay, so let's set up a Git repository for the R Markdown file we just made. So to do that, I'm going to come over here. Yell too badly at this. Okay, so this is a folder that has, so these are those files, okay? So we've got some annoying little system file, we've got this penguin observation data, this is the markdown file, and this is the HTML. And I want to start tracking this, any changes I make to this using Git. And so in order to do that, I have to first create a Git repository. And I just do that by typing git init. And now you see this little thing shows up, right? So now we're all ready to go. We haven't made our initial snapshot, but we're ready to do that. Confusingly, we loosely refer to the entire folder as the Git repository. You might be like, oh, I've got this repository here, it's this folder. Even though the repository is actually the little jazz inside here, okay? So but we still kind of colloquially say like, this is my Git repository. This whole thing is my Git repository. But this is really all three of those areas, the working directory, the staging area, and the repository that's holding the snapshots. Does that make sense? Like kind of like, yeah, okay. So now I'm gonna say, status. So these are untracked files. So these are files that are sitting on the shelf that have never been added to the shopping cart, that have never been checked out to make this first snapshot. So, okay. And I want to do the thing. There's a little thing we need to know about. Okay, so keep in mind here, so just bear in mind we've got 1, 2, 3, 4 files here. Okay. Notice anything different down here? Anything disappear compared, sorry, I know it's kind of scrolled off the top. This is what it was before. This is what it is now.
DS store thing is not there.
Yeah, exactly. So, and we've added this file called gitignore. So in Git, it's actually really useful to have control over not tracking all the files. If we have these annoying little system files like DS store on the Mac, I'm sure there are tons of these on Windows computers, or maybe just something very specific to like my operating system that I don't really, want to track in a repository. Or maybe a file that's like super duper large. I have like a data folder and it's got like files that are like, gigabytes of information. You wouldn't normally track that. So gitignore is a way to say to Git, so I'm just gonna, all the gitignore file is just saying, hey, I don't want to track this file, ever. If it's in multiple directories, you can do */ there's other things. And so you just list all the stuff in here you want Git to ignore. Okay, so going back to this. Yep.
So if you want to ignore more files, you just enter and enter more files in the next line.
Yeah, like my gitignore is like this 3-page list of random junk, that I'm choosing to ignore. It doesn't have to be that bad, but like R generates some of these weird background files when you're using R projects and things of that nature. So you just add them line by line. Does that answer your question? Yeah, totally. I even have like a generic one that I use on my computer. I put it in like the config folder that for Git entirely, and so it's like all those things plus whatever specifically I'm using. So you can have multiple gitignores. I have one for my overall system that's in like my root directory, and Git sees that and it's like, we're going to ignore DS store. And then for a specific repository, I may be like, all right, ignore this data folder. And then so I just have a new gitignore that's just data. And so Git takes both of those and looks at both of those together. So you don't always have to recreate the wheel with that. Does that make sense? Yeah, okay. Coming back here, so let's go to Git status again. So now these are untracked files in our repository. If I do this, Git add them all. Where do you think we've put these now? What do you think how do these green things differ from these red things?
In staging area.
Exactly. So we've gone to the working directory, we've grabbed these files, we put them in our shopping cart. We're like, I want to commit all these things. And like I said a moment ago, we don't commit everything at once, but usually for your first commit, you just commit the entire state of affairs, like for your initial snapshot. Like I wouldn't for my initial snapshot make a million little separate commits. I would just dump all my files in and make one snapshot to start. And then as I modify it, I would be more granular. So the git add command is the essence of going to the shelf, taking the change and putting it in the shopping cart. And then to actually do the commit, you type a message, commit. It tells you some stuff. I do git status. Okay, so now it's telling you nothing to commit, working tree clean. This is just Git's obtuse way of saying the snapshot that exists in the repository, the most recent snapshot, looks identical to the files in your working directory. I see no difference between these two things. So you're clean. So this is like saying there's nothing you've done since the last snapshot that is different from what you had before. Does that make sense? Okay. Last thing. So this is that SHA value. This is like that unique hexadecimal value that comes from the particular data that I put in here, my name, the fact that I wrote initial commit. This is like that unique representation of this data. And the more commits I make, the more they're just going to appear. So this git log tells you like the list of those commits. This is that tape player starting to work in action. Does that make sense to you? Okay. Okay. Let's go. So you can do all that on the command line, but RStudio also has this like GUI for interacting with Git, and so I'm going to show you how that works if you're not used to that. Let's see, and I'm going to show you how to do basically the same steps there. I do it on the command line, but I often also use the RStudio GUI all the time, because you're right, a lot of times you're just right there coding in R. It's just handy to be able to make commits in that place. Okay. So here I actually need to make a new project. So the key is you have to actually make a project. So I'm going to do that. You go to new project, to existing directory. I'm going to find where this is. This is probably on my desk. one is? I'm going to create this project. Does everyone know what an R project is? Within our projects is like a little tiny container that like you point to a folder and you're like, this is a project. So just kind of, it allows our studio to kind of do more things for you, like keep track of the files that are in there a little better. Like it provides these hooks into like things like Git or directly from within our studio. So think of it just like a little briefcase for like whatever you're working on that allows this extensibility out into our studio. And I should have shown you this before, but before I created this project, this wasn't up here, this little Git thing over here. There was nothing here. But when I created this, our project, our studio went and looked in the folder that I pointed to and was like, oh, this person has a Git. This person is tracking changes using Git. I'm going to link into that Git directly within our studio. So that little thing my cursor's on right here, this guy, this wasn't here a moment ago. But once I made the project, now this is the project file, our project file. Picture this is like storing a bunch of stuff you don't need to worry about that's related to this project. It puts this up here. And let's see. And actually, let's see. Okay, so now I'm just going to step through those, how you would do that right here. So these are actually things now. Does anyone know why these things are showing up here? These two files, any thoughts? I'm going to go back to...
Did they change?
Yes, exactly. Things have changed. I do Git status here. I've got two things. We didn't change this ourselves. Our studio did this for us, right? But we have a file that's modified. So we're in the supermarket. This Git ignore is on the shelf. It's different than it was for the first snapshot. We're in the supermarket. Someone took reproducibility example, .proj, and put it on the shelf. So now it's saying, hey, what's in my snapshot is very different from what's on my shelf. So these two things, if I type Git status, it would be showing me in this sort of like non-intuitive way. And then back over here in R, it's doing the same thing. This is just showing it to you kind of live. And let's quickly look at the Git ignore file. So I'm going to cat, because it's and when we created the R project, R went ahead and said, you know what? I'm going to make this annoying little system file called rproj user probably. You don't need to track that. It adds it right to your Git ignore for you. So this is what you were asking a moment ago about having multiple files in the thing. So this just puts it on the next line. And so it's updated that file for us. And so before we did this with add and commit. Let's go back here. We're going to do it over here. So if I select this, this is me adding it again to the shopping cart. Where's the little, sorry. Sorry, I'm blanking on how to actually do that.
Is it up arrow?
Yeah, I think so. Sorry. Weird. This is actually for pushing and pulling. It might be, yeah, this one. Okay. Sorry. Moment of panic. So here's that file, right? So if I click on this. So this is what's called git diff. This is incredibly useful in general. So it's showing you what's different between the file now and the previous snapshot of this file, right? So this green line is saying this is a new line. You could have a red line which is saying like you removed the line or something's been modified. You can do the same thing with the command line by typing git diff in the name of the file. But here it just kind of shows you really nicely. And so this is saying, this M is saying it's modified, and this question mark is saying it's new. Okay, so now we're going to actually do the commit over here. Whoops. So we're going to, this is again adding this to the shopping cart. I'm going to say as rproj or something like that. I'm going to commit. And I'm going to close. And now you notice over here, nothing's there, right? So now this is the exact same situation before where Git is like, hey, your newest snapshot matches what's in the working directory. So we took the initial snapshot and we updated it with these two things. then if you want to see the log, I think it's actually this guy. And so here we go again. So this is just a GUI representation of, this is this is where we're at right now. The head's pointing to this point. We made this particular change, which is shown here, and we built off this last snapshot. So we have 2 snapshots in this repository. Does that make sense? So everything you do with Git is basically that, you know, more or less. Okay, so how do we work with teams using a shared repository? Remember, this is what we refer to as continuous integration. And so to do this, we use GitHub, which is just one of many web services that lets teams use Git together. And so in this case, we now have a new repository, which is called the remote, this thing over here. And that is linked to our local repository. So at this point, we've described this, right? We have add to the staging, commit, and so on. I didn't talk about reset, don't worry about that. That's kind of like taking things out of the staging area. And there's another term for going backwards in time in the repository. This is a remote repository. So this actually sits up on like a web server or some service. And what we do is we push and pull our changes from our local repository. We put them in the remote that way. So there's this extra step of moving snapshots from our local repository to this remote one. And Git is smart enough that many people can work in real time on the same files, or even the same file at the same time. And so if a file is changed sequentially, like if you're changing a file and you're changing a file and you're making changes in sequence to that and you're pushing or pulling those, it's almost like you're passing a tennis ball back and forth. Like you make some changes, you put them up on the remote, he pulls those changes down, you manipulate the file and you push it back and go back and forth. And that all sounds really hunky-dory, but in cases where you're actually both making changes to the same line of code at the same time, let's say you're working locally and you change like lines 15 to 20, and then you pull and he's also changed lines 15 to 20, Git is like this great traffic cop arbitrator where it's like, hey, I can't deal with this. You both made changes to this part of the code. I don't know which is right. You sort it out. And it literally just puts both of those, it's like right in the file. It's like your changes, pick between these two, I don't care, and then make a commit. That's called a merge. We're not going to talk about that. So it's basically there to catch this thing where you both are modifying the exact same areas at the same time. Does that make sense? Okay. Okay, so what we're going to do is we're going to make a remote repository on GitHub, and we're going to link it to our local repository. We're going to do a push and pull to that to show how that works. And we're going to deal with that weird comment that we had before as an issue. So let's do that. Okay, so here we go. Okay, so this is GitHub. This is that web service I was talking about. We're going to make a new repository. We're going to call this repro example. Here we're going to make this private. You can make this public. There's lots of things you can do on GitHub. GitHub is kind of like almost like weirdly social media in a way for Git. Like it has all these like extra things that you can take advantage of. Okay, now we've created that. So what we're going to do is it's unlinked. So right now it's sitting up here. It has no idea about your local repository. It's like they're separate universes. We need to actually glue these things together before we start doing that. So what we do is we use this particular step. So now I'm going to go back to it's easiest to do this with the command line, so you kind of do this one time with the command line. Actually, if I do this right now, hold on, Git remotes. I forgot the command, so I'm not going to worry about it. But basically, there's no remotes linked to this. And once I do this, yeah, now it shows, see up here, when I type git remote-v, nothing appeared. After I run this particular command, which I just pasted over from GitHub, you don't even have to know what it is. When I type it, it's saying, oh, this is where I'm going to be pushing to, and this is where I'm going to be pulling from. It's identified that remote repository. They're connected. Let's do this. So now let's take so if I do git log, here we are, here's our log from before. So this is our second snapshot. If I go back over to here, there's nothing, right? Even though we've connected them, we haven't pushed anything up to it, because it's still kind of like a blank slate up there. And so pushing, we use the command called git push, and for the first time you actually have to point to the remote's name is actually origin. I should have said that. So you can name it anything, but it's sort of like typical to name it origin. So origin here will be this link to this Git folder. And we're on the main branch. Again, we're just using one branch, so we're calling it main. And so if I type this here, hit enter, some stuff happens. And now if I go back here, hopefully, ta-da! Okay, so now this is all the stuff we had here before. So this is like up on the remote. So picture many people connected to this one thing, doing things at once. Okay. This time I got 10 minutes, right? This is a full hour, right? It goes 12 to 1. Okay. Okay, so that's an example. So what we did there, just a moment ago, we pushed our snapshots up to here. So if you made some changes and you were going to work with those changes, you would go to your local repository and you would type git pull, and you would pull these snapshots down, whatever he's done, down to your computer. And you can also do this, again, in our studio. I'm going to shut this. These were grayed out before, now they're not, because it's live, it's seeing that you have that. So if I click pull, it's saying you're already up to date. So that's saying your computer, because it's my computer, right? So everything's the same. So it's saying the snapshot version that exists on my computer matches what's in the repo. So this is like an analog to like when you're comparing your working directory to your repository and you're saying they're the same. This is saying like, no, everything you've got everything that's been up there. There's nothing that's different. So again, it's comparing those two things.
So for the other person, it would show the record of the changes, right?
Yes, like so if you made some changes and then you pulled, I don't know why I keep picking on you two, but like, yeah, this is my head. So you pulled them down and you type git log before and after, like before there would be nothing there, and then afterwards you would see the two changes that he made. And then so if you made changes, you're putting yourself in the same tree, they call it, so you're basically making changes to the same set of files. So you're all part of this like intertwined git log as to what's going on. You don't really have to worry about most of that. You really just have to know the 5 commands and then you're kind of good to go. And you can do all that with clickies through our studio as well. So I know this seems complicated, but don't let it feel like you're like in the bowels of Git all the time. You're really just honestly using these 5 commands. Okay, so GitHub includes a lot of what can be characterized, as I said, like almost social media features for making it easier to more fun to work as a team. And one way GitHub really shines is dealing with tasks. So let's revisit this comment from before and treat it like a task to be done in GitHub. So we're going to do that with issues. So issues is a feature that allows you to track ideas, feedback, tasks, or bugs for working on GitHub. And so either collectively as part of your team or with your end users if your code's public. So I don't know if you guys in the past have used some piece of software and there's a bug or something confusing and you go to the GitHub page and you post an issue, or you look at all the rage in the previous issues and you're like, how does this work? So I'm going to show you actually how to make that, and this is exactly doing that. And so we're going to do that with this cryptic example. And so I'm going to do that now. So I'm going to come over here and I'm going to say, I'm going to make a new issue, and I'm going to say, okay, remove, whoops. I'm going to say new issue. Say remove Hard-A 2015 Delhi data. Put that in here, and I'm just going to say submit as issue. Now this is saying to do a thing, okay? And so then I'm going to go over here back to our, and close this. I'm going to come in here and I'm going to, let's see. I'm going to say end site key equals RNA 2015 Delhi. Because this is that data. So what I'm doing, sorry, I'm not being very clear. So there's in my data, there's a source from this particular paper that has this site key. And so if I showed you the data, you would see some rows for penguin abundances that have this on them. And I decided I want to remove those because GH, whoever that was, says that's not like validated in use. So we're going to drop that. So now instead of having that collection of files, it was all confusing, I'm going to make the change to this one file, and I'm going to save it. And immediately when I save it, you see something pop up over here on the right. So already Git is like, hey, you're different. Your working directory is now different than the previous snapshot. Then I'm gonna knit this file, which we know what that means. Boom. And then this is now different. Oh, I made a mistake, but it doesn't matter. So I said only equals that, but I need to say not equals. So now I've dropped those particular data. Now you'll notice another file appears here. And so now I actually want to document, so now I actually want to, I'm going to version control this, and I'm going to continuously integrate it by loading it up to Git. So this should make a little sense now. I'm going to do it right here. Again, this is diffing, right? So here, this is what the line was before. So when you're writing your message and seeing this is incredibly helpful, this is what it was before and this is what it is now. So it's showing you exactly what changed. For the HTML, we don't really worry about that because it's so big. And I'm going to say removes bad data. And here's the best part where you go closes number 1. Then I'm going to commit this. Okay, so if I've just committed this, where has this change now been snapshotted? Is it on my local computer? Is it on the remote? Is it on both? Like where is this change? Where's this change, this new snapshot recorded at the moment?
This is to your local computer, right?
Right, exactly. If I went over to here, that issue's still live. And if you look at the data or the log, there's still only 2 commits over here. So very much. So now if I go over here and I push this, and then I come back over here, and I update this, notice 2 things happen. 1, this issue closed and I have that 3rd commit sitting over here. So if I go back to my issues, and I look at this closed one, boom. So this is actually linking that chain. I've done this commit actually fixed the problem. I could write a whole bunch of comments. I could have a discourse between me and whoever GH is to argue about like whether we should remove that data. And it's all kind of version controlled in the issues thing. So it's a really easy way to actually keep track of this stuff. Okay. All right. How much time do I have? I have 2. Just give me 2 minutes. And I'm not going to. The stuff I had about RMB was kind of extra anyway, and so I just wanted to throw it in there. But okay. So again, very confusing, very powerful. Don't let this stop you. Try using it with your own work with really simple cases. And these are the only commands you're really ever going to use, like 99.5% of the time, unless stuff goes pear-shaped on you and you need to actually roll back and fix some things. And you can do all of this from within the RStudio. And the last thing is I just want to mention our computing environments. So just to say that, in this case, your computing environment changes over time, like both for you and for others. And this R package RENV offers this partial solution. These are the only commands you wind up using with RENV. You're basically initializing what package you're using. You're making a snapshot of that, and you're restoring that if you're on a new computer. And this stuff is all added to Git. So it's all version control directly within Git. So if you snapshot your R computing environment, the snapshot will go up to Git. You pull that down and you type restore, and like whatever packages he was using, and by packages I mean the exact packages and the exact location in their particular Git development stream will be on your computer. So this is the way we match that together. And just briefly, this is just sort of showing that. And there's this R lock file that gets pushed up. This is what's being put in Git. So this would be you and this would be you over here. So it's a way to like share your R computing environment with one another. And I'm not going to step through that, but it's actually pretty easy to do through the vignette. And the last thing is containerization, which I was going to skip anyway. But basically, all that happens here is you have a Docker image, which is just the minimum amount of software needed to run your code. That base image you get from this Rocker package in R. and you customize it in R using this Docker file to modify it to how you want. And then you include things like, again, you include RENV in this Docker file, your code and your data. And then that image just sits, picture it like a non-executed thing. And then you make a container of that by activating it essentially. And then that creates this RStudio environment in your browser that's literally like a miniature world. It's like whatever you put in there, your R environment, all your data and code, and like all the little system files. And it's just basically a tiny little Ubuntu, Ubuntu system running right there on your thing. So this extends that RENV idea from beyond your R environment to your computer as a whole. And that's, we'll skip the long name, and that's all I wanted to say. Does anybody have any questions about that? Or any of what I presented today?
So Docker works with Python or C as well, right?
Yeah, it works with everything. It's not,
Just
I'm using it
make
in
this.
our example, but you can use it for any particular type of computing environment. Yeah, so those R packages are designed specifically to interface with Docker in a way to make it easier for you to kind of like, they have these bespoke images, like where they've got like different R compute environments already loaded up for you. Yeah, good question. Anybody else? You guys are thrilled.
I have some philosophical question.
Yeah.
So, usually when you see someone's code, it's easy to read and so on, well documented usually. Yeah, but what if somebody decided to create some really efficient function, like some crazy linear algebra that you really don't understand from the first place?
Yeah, that's a.
What would you recommend to do in this case? How
Well,
to write this code so that other people will understand?
There's this trade-off or tension between like how clever we are and often how clear and transparent code is. Do you know what I mean? Like you could write some, like for instance, I could write a bunch of for loops to do something and it's like really obvious. Or I could do what you said, like some matrix algebra that's like, maybe more complex or esoteric, but it's much more efficient. And so when you do that and someone's looking at one line where it's like the Koleski decomposition of whatever versus like some more brute force approach, it's less transparent and so less reproducible. But this is the thing, like reproducibility is a target. It's not like you can achieve this perfect reproducibility. So sometimes this just happens. And I would go with whatever, the more elegant, like clever solution. I think the only thing you can do to mitigate that is to be really good about documenting what happened there. And so like you could have like a separate markdown file where you're like, hey, I did it this way. This is like the math of what's happening. Here's like an image, like a heuristic diagram that like shows like what that is. This is the name of that function. And then that function is going to be used throughout. That way someone can actually go and understand like what that function is doing. So I think documentation with, like I said, markdown, because you can put it all together, is like your friend in that regard. Does that make sense?
Yes.
Yeah. Any other questions? No? Okay. Well, when you leave, make sure you initial next to your name so I can give that to Jennifer so I know that you attended. So, yeah. And I'm still here if you want to ask questions like afterwards.
Thank you.
Thank you.
Yeah, you're welcome. Thank you. Was that helpful or clear in any way, or was that, like I always try and gauge, like, do you guys know all this already? Or was this kind of new or a mixture?
I
Mix.
think we have released version session for the session 2 in PDP.
Oh, someone else did get as well? Oh,
Yeah.
okay, I didn't know that. We probably should coordinate with that. Yeah.
No, I think like this one was a bit more detailed in the sense that it like actually showed the code and everything, and it was really useful for me. Like I've been using it for like 2 years, but no one really added to me. I just like start using it.
Yeah, I know. Right.
But for once, right now everything makes sense.
Okay, so that makes sense, the description of,
Yeah.
okay, that's good.
Yeah, that's very good.
Okay, thanks.
Thank you. Thank
Yeah.
you.
Here, thanks for doing that. I was just about to come and